Hi everybody, my name is Grace, and today I will be discussing and evaluating methods for studying the North Atlantic right whales. So I wanted to start off by giving a little species overview. So the North Atlantic right whale is a critically endangered species living just off the east coast of the United States. There are around 380 individuals remaining, yet their populations continue to decline, which is why studying their movement patterns to define critical habitat is essential. And you can see from this picture on the left here that they have very short pectoral flippers, no throat grooves like other baleen whales do, and no dorsal fin, which makes them very unique from other whale species. So let's start off with the issues with current research methods. That's kind of our criteria for assessing other methods. So current issues are that tags can be highly invasive. We can't always individual or ID individuals, and sometimes we get inconsistent data. The first method that we will cover is passive acoustic monitoring, sometimes known as PAM. So passive acoustic monitoring is when we use underwater microphones, aka hydrophones, to record whale vocalizations in the ocean. The hydrophones are typically mounted on a buoy or simply in the ocean floor, as you can see on that far left image. The pros of this method are that it's non-invasive and can be used for long-term monitoring. The con, however, is that we can't identify individual whales based on their calls, so it makes it very difficult to use this method for individual movement data. And here's an example of a North Atlantic right whale vocalization, and the specific call is called an up call. So that was passive acoustic monitoring. Now we will shift our focus to the next method, satellite imagery. Satellite imagery uses satellites in space and takes large-scale photos of the ocean surface. We can use imagery from other established projects already and use AI algorithms actually to identify whales. The pro of this method is that it's non-invasive. The cons include inconsistent data since they're not always on the surface and the inability to correctly identify individuals. The image on the left is actually an example when we could identify an individual just because of that bright marking on his back, but since most of these whales only have markings on a small portion of their head, satellite images tend to be blurry, it usually is hard to differentiate them. I also want to note that this method is great for assessing large populations movement data, so we can easily see big pods, but in our case of a declining species, it could be a bit more difficult. And that was satellite imagery. So now onto our number one method, satellite telemetry. So satellite telemetry uses tags attached to whales that send signals up to satellites in space. The tags often measure location, dive depth and time, water temperature, and sometimes even respiration rate. With this, we can directly track the whale's movements. Usually, telemetry tags on large aquatic species would be placed on their dorsal fin, but as I mentioned before, right whales don't have them, so instead dart tags must be inserted into the blubber where the fin would otherwise be. And here is a graphic from NOAA that illustrates what this movement data would look like. The pros of satellite telemetry are that it gives us consistent movement data with transmissions every time the whale surfaces and accurate identification of individual whales. A con, however, is that the invasiveness of tags can potentially cause harm to the whales if not properly used, but I will discuss shortly how we are kind of overcoming this recently. A study by Gulland et al. Published in 2024 found that roughly 15.6 to 26.5% of tagged whales experienced deep skin depressions, and around 2.2 to 2.9% experienced subcutaneous swelling. They suggested that this was relatively low and that satellite telemetry was still one of the best methods for studying whale movement overall. A recent modification as a method to this solution uses non-invasive suction cup tags. While using these is much safer for the whales, we do trade off long-term movement since they fall off after about 24 to 48 hours. But with the use of drones, like that image on the right there, to attach suction cup satellite telemetry tags, we could repeatedly monitor the same whale, which is replacing it once it falls off. And all of this aside, satellite telemetry is one of the best methods we have for studying movement patterns of the North Atlantic right whale due to individual identification, long-term data with some tags, and it's relatively non-invasive. And that was all of our methods. So thank you so much for watching. I hope you learned a thing or two about whales. Here are a list of my references.